Next I'm going to show you what happen when a magnetic external magnetic field is applied on magnetic dipole. Okay, so suppose this is our magnetic dipole. Suppose this is our magnetic this is our external magnetic field. Okay, this is our external magnetic field. Now a dipole is placed in this field in the direction making an angle theta with B. So this is our dipole, magnetic dipole, and it makes an angle theta with the magnetic field. Okay, that means since magnetic dipole moment is along from A to B, so say A to C. Since magnetic dipole moment is along A to C, that means at C we have a north pole and at A we have a south pole. So at C we have a north pole and at A we have a south pole. Okay, so we know that a magnetic north pole feel a force in the direction of the field. So this pole feels a force in this direction by an amount m into b, and since at a south pole, so south pole feel force opposite to the field, so by the amount mb. AC, say AC is 2L, so this two force, resultant force is equal to, since the force are opposite, so resultant force is equal to 0. But one thing happen, since the lines of force of the two forces, line of action of the two forces, okay, line of action of these two forces, these are the line of action of these two forces are not in the same line, rather they are different line. So when the two forces acts on different line, means their line of actions are different, then a torque acts on the dipole, and the torque is nothing but, how do you define torque? Torque is nothing but force into the perpendicular separation between these two forces, perpendicular separation of the line of action between these two forces. What is the perpendicular separation between the line of action? Is AD. AD is the perpendicular separation, so this is your AD. Since this is theta, so this is also theta, so AD is nothing but AC sin theta. Okay, AD is nothing but AC sin theta. So your expression now becomes m into AC into B sin theta, and your m into AC, you know, the pole strength into AC means separation. This is called dipole moment. So this is dipole moment mb sin theta. Okay, so your torque is mb sin theta. In vector form, your torque is m cross b, because a cross b is ab sin theta. So this is your expression of torque. That means when a dipole placed in the magnetic field making angle theta with the magnetic field, a torque acts on the dipole. Due to this torque, this dipole rotate anti-clockwise direction. Okay, the dipole rotates in the anti-clockwise direction, and hence due to this rotation, ultimately this torque becomes parallel to the applied field. How? Look, it looks like this. Okay, I draw some good drawing over here. Okay, I show you how this rotation happen due to this torque. So this is your magnetic field. Okay, initially your dipole is in this direction, but due to this torque, the dipole rotate in the anti-clockwise direction, and ultimately this torque becomes parallel to the applied field. Okay, this torque now becomes parallel to the field. When the torque becomes when the dipole becomes parallel to the field, then theta is equal to 0 degree, and torque now becomes mb sin 0, that is equal to 0. That means no more torque acts on the dipole, and dipole becomes parallel to the applied field. So this is the case when a dipole placed in the external magnetic field. Okay, ultimately the dipole aligned itself parallel to the magnetic field. That means its dipole moment vector becomes parallel to the magnetic field. Okay, try to understand this. This similar thing happened in the case of electric dipole. Okay, na? In the case of electric dipole, this same thing happened when an electric dipole placed in the external electric field. When an electric dipole placed in the in external electric field, there is also a torque act on the dipole, and as a result, the electric dipole plays parallel to the electric field. So this is the electric dipole. So this is angle theta. So torque act. Due to this torque, anti-clockwise rotation happened, and as a result, ultimately the dipole places itself parallel to the electric field. When the dipole places itself parallel to the electric field, then your theta becomes equal to 0. So then torque is equal to 0. No more torque act on the dipole, and dipole come to rest. Okay, this thing happen. You have to understand this scenario, because this situation for the case of magnetic dipole, we apply these things, this concept for our magnetic material.